So hello all, am I audible? Yeah. So hello all, so hope you had a great lunch. So let's start with the topic, serverless micro-VMs for containerized applications. So my name is Neeraj and I am working as a senior software maintenance engineer in Red Hat, India in OpenShift team. So here is my co-speaker.
Hello all, my name is Nikita Sanjay Patwa, working as a software maintenance engineer in sustaining engineering team at Red Hat, India. So let's see what we are going to cover today. We are going to check about serverless micro-VM for containerized application. The agenda that we are going to check, we are going to check about the cloud native evolution, how the cloud native has evolved till now, what was wrong with the traditional serverless thing. We would check about the difference between the micro-VM, the container, and the traditional VMs. We would also analyze what exactly micro-VM is. We would also learn about the anatomy of micro-VM, what things a micro-VM requires. We would check about some micro-VM providers. We would understand Firecracker, Ignite, Kata containers, Knative. Don't worry about these terms. We'll move forward and you'll get familiar with that. Then we would just give you a demo of it, and we would also understand some of the organizations that have been migrated from their traditional ways of cloud native to micro-VMs. So let's start. Now let's begin with the evolution of cloud native. We were having our traditional VMs first, which were giving us strong isolation, but again, they were slow and having a low resource, having a much resource overhead. So that was using your system resources with much more things. Then to replace VMs, they came into picture container. So container was having your application with its dependencies. And it was fast and lightweight too, boots faster. Moving towards serverless. So serverless means you do not need to worry about your infrastructure. Just go and run your application, and your application would start working. Then came into picture micro-VM. So it's a combination of both the tech worlds, that is your VM and your containers. So it is having a VM-like security and container-like fast boot-up time. What were the challenges with what are the challenges with the today's function as a service? First and the foremost thing is it is having a weak isolation across the tenants. That is, if you are using your application into a container, so your container is deployed on your host operating system, and if an attacker is having access to your host operating system, then your container is also breached. So here comes the security threat. The second point is cold starts and with unpredictable latency. So cold start means what? You need to first look up at the setup, all the setup you need to do for your application, and then you need to run your application. And that leads to a delay, which is very cumbersome. Moving towards next, it is having limited control over your OS. And again, the security part, it's difficult to have the isolation thing, as I mentioned earlier about the attacking surface. Now let's understand what is micro-VM. So micro-VM is nothing but just a lightweight virtual machines which is having speed, efficiency, and strong isolation. It combines the security of VMs and startup time of containers. And it is having a low resource overhead too. Where we can use micro-VM exactly for multi-tenant approaches and to run your small applications in a quicker manner. Multi-tenant is if there are a number of users and they are using a shared system, so you can have an isolated environment with it. So key features, as I already mentioned, having a fast boot-up time. It is providing your full isolation. It supports your open container images. So that we would look forward how it supports open container images. And again, it's with minimal overhead. Now let's check about the differences between the VM, the container, and micro-VM. First, we'll go across the design aspect. So in traditional VM, we were having a fully virtualized environment. For the container is having your application and application environment with the shared OS. It shares your host operating system. And micro-VM, it uses its own kernel, its own root file system. For the isolation part, traditional VM provides you the complete isolation. Container just provides you the application level of isolation, and micro-VM, just like the traditional VM it provides a strong isolation kind of thing. For the performance thing, traditional VM uses much more of your resources, and it takes time to boot because it's a complete OS you are using there. For the container, it's resource efficient and having a the startup time is more. For micro-VM is also small overhead and it is having a quick startup time. Now, where we can use all these things. So traditional VM is basically used when you are having stronger workloads. You can go for traditional VMs. For containers, if you want to just manage your application with the dependency thing, you can just go with the container approach. And if you're working with micro-VM is best suitable for the multi-tenant workloads. What exactly a micro-VM requires? It's nothing, just a kernel image, a root file system, and an API server. So it requires the volume, that is the root volume, and your kernel file system. It doesn't care about your bootloader. It does not require bootloader. It's just load your kernel directly into the CPU memory, and your micro-VM would be started. Now, how the communication takes place, like if you are giving any of the resources, so if there is no bootloader, how the communication would take place. So there is API server that would take care of each and everything. There are some of the micro-VM providers. We have listed some of them here. So first one is Firecracker, which was created by AWS, and it was mostly used for serverless computing by AWS Lambda and AWS Fargate. For Kata container, the next came into picture the Kata containers. Kata container best suits if you want to integrate your micro-VM with your Kubernetes. And it was developed by OpenStack Foundation. Then came into picture Ignite. Ignite is similar to a Firecracker, but just for the ease of user, Ignite came into picture, and it was created by vWorks. We would understand in depth all these things. Let's move forward. What exactly Firecracker is? It's an open source virtual machine monitor that was developed by AWS, as I explained you in the previous slide. The boot up time that it requires is less than 150 milliseconds, and the resources that it uses is approximate about 5 MB. How does it provide a secure environment? So it is having a jailer and seccomp in it, which gives you a chroot environment so that you can securely work around your application. Where we can use Firecracker, so it can be used for short-lived processes, for your isolated workloads, and to run your multi-tenant applications. Now, as I mentioned you all, here is your client. So client will give the request to the API server, and the API server would take care of your network, storage, metadata service, rate limiting, everything that would be taken care by the API server. I would explain the commands in the next slide. Yep. So the first thing you are seeing here is the Firecracker command. It's basically we are hitting the API server. We are just creating an API server, that's a socket file. Now we would hit the API server with the boot source. We would tell our API server, hey API server, this is my boot source, just boot with this image. Then you hit your API server with your root file system. You go and just tell your API server, this is my root file system, just boot my micro-VM with that. You give resources, whatever resources you require, like the CPU count, the memory size, anything, like whatever you require, you just give into your resource count into your machine config. Then you just start your instance. You would hit your API server with the actions command and state in the JSON format as action type instance start. And if you want to stop the image, just send the action as send Control-Alt-Delete. Isn't it very tedious for a user to have a knowledge of all these commands? Like it's very, a naive user won't be able to use this. So there came into picture Ignite. So Ignite provides a simplify thing. It's like it provides a Docker-like CLI, like Ignite. It provides you with the command Ignite run, Ignite PS, etc. It pulls your image and then boots your VM. So you have your Ignite, and in the backend, it is using Firecracker itself. It is having all the built-in networking volumes. So Ignite takes off everything. You don't have to worry about giving the root file system explicitly, about giving the boot source, about giving the resources. It just fire a command, and then everything would be taken care of at the backend by the Firecracker. These are the basic commands. First, you import the image via the Ignite image import command. Then, just like the way you do in Docker, or podman, then you just check about the images, ignite images. And if you want to run, just do ignite run, give your image, the name of your VM, the CPU you want in your VMs, the memory usage, the size, and just do SSH, so you have an SSH access to your machine. So these are the basic commands. Yep.
So now let's see how we integrate the Firecracker MicroVMs with Kubernetes. So what Kubernetes provides, right? So what traditional Kubernetes isolation provides? It provides isolation with the namespace and network policies, right? By default, Kubernetes offers namespace isolation, RBAC access, network policies. Okay, and it works with runtime class as well, right? So it also provides policy enforcement and tenant separation made easy. Also, after that, we are giving the runtime class over here. So runtime class we are using is Kata container runtime. So why Kata containers we are using over here? Because it provides the binary Firecracker which helps our pods to run inside the micro-VMs. So this is the architecture stack which we are looking for. First we create our function, which is again nothing but sort of a knative function. After that it implements inside the pod. It is using the Kata container runtime, and after that in the background as we read that it uses Firecracker, which is nothing but a VM monitor, right? And after in the background it's using Linux kernel, which is KVM. So let's see about the normal deployment. So this is how our generic deployment see, right? So the only one change which we need to do over there is runtime class. You can see on the top we have the runtime class. So over here we provided that Kata-Firecracker. FC means Firecracker. So we just provide the Firecracker runtime over here. And if you say kubelet get runtime class, you will see the Kata container and the handler is Kata container FC. So what it does we will see in the demo part as well. For next, okay, so what about Knative? So how Knative integrates over here? So what Knative provides is the build to manage the serverless workloads, right? It uses the Knative to define event-driven workloads. Behind the scenes, it creates pod with Kata container runtime. Auto scaling is also provided by this by the Knative serving applications. So what are the benefits? It's for rapid deployment of serverless applications, or the routing is already managed. So what are all the benefits using with Kubernetes? As we all discussed that Kubernetes provide all the things, networking stack, pod deployment strategies, everything. So we will be deploying the container images and Firecracker based on micro-VMs. What next? So here is the Knative function service. So this is the sample service we can see over here. So on the top you can see serving Knative. This is the API server which defines that this is a Knative serving. You can see the kind over there, and the spec section again we are seeing the runtime class over here, right? Kata-FC, and remaining things are same. Remaining the things are the container image, ports, and we are seeing the arguments, right? So first of all, we need to enable the feature of Kata container runtime inside means runtime class. So we can see over here inside the Knative serving, right? In the configuration feature, we need to enable the feature which is runtime class name. You can see it's enabled by it. We have enabled this thing, right? And this is the Chorus system, which is the KGET SVC. Inside the Chorus system, Chorus is the ingress gateway for the serving Knative application side. So traffic goes via courier internal, and then it is sending it to the pods. So let's see the demo part. So wait a minute. So here we can see that we have a Kubernetes cluster with a single node for this session. So we can see all the pods are running over here. We have the etcd proper working, and Calico networking has been placed in the place. So and after that, we will just check the deployment which we have seen in the slides as well, right? So over here again, the deployment, and it is a flash deployment. There is a sample application which we have created. The replica count is 1. Again, we can see over there runtime class is Kata container FC, which is nothing but a Firecracker runtime, right? Over here we have provided the image and the container port, which is already provided over here. So let's remove if we have anything already created. Let's remove it. So we create this deployment, right? So we just initiated a deployment and we created it. So now let's check what a pod is created. Okay, so pod is created, right? So now we will verify how this particular pod is running inside the micro-VM, or it is a normal runtime using. So by default, you can see we have mentioned this. So it is using the Kata container Firecracker runtime over here. Now let's see inside the CDL PS, right? Over here we get the pod ID. Again, it is running as a pod as we see. So there is nothing to change over here. So that is the beauty of the integration with Kata containers, with Firecracker, with Knative. So it is running the, you can see this is again pod, and this is a container process. So over here what we are doing is we are just going inside the virtual container and the subsystems over here. You can see sandbox over here, and we are seeing that there is one file which is mentioning all the details. So over here we can clearly see that hypervisor path is Firecracker. Nothing by default. What we see is when we run a container, it's using runc. It is using over here. We can see we clearly mentioned the Firecracker has been used. You can see the kernel path as well. You can see the kernel path here. Here all are the kernels placed right inside Kata share Kata containers. All the containers are different places, right? And all the container images also present over here. So we are using this Kata Ubuntu image. You can see over there it is already used. So you can see all are the binaries as well. The jailer binary is also present. Firecracker binary is also present over here. So you can see inside the Kata binary, we are seeing the Firecracker binary as well and the jailer binary as well, which is by default implemented by the Kata containers, right? So now we will be seeing going inside the pod. Let's see if it is actually using a different kernel. So over here we can see the kernel name is 6.12 and the name of application is Flask application. Now check, we will see our systems kernel. We can see this is the DevConf machine and the kernel is entirely different. So again, this is a sample deployment of an MicroVM. This is how we implement the normal pod and the MicroVM. Now let's see about the Knative part, right? So I will be just explaining about a bit about Knative architecture deployment first, and post that we will be seeing about all the deployment, how we deploy the Knative function over here. So first, the activator function. So it buffers the incoming request and it forwards them when the pod is ready. So this is the role of activator. So autoscaler, nothing much says that it will autoscale according to if there is a memory spike, CPU spike, or let's say if the concurrent RPS is increasing. So it will be attacked accordingly. Next we have the controller part, which is watches the Knative service, configuration and revision and routers. Okay, and next we have the courier controller, right? What it does, it controls the courier ingress in the application. So next the webhook, it validates and mutates the custom configurations that the schema must be same and all the things, right? Now let's see the deployment. So now let's see that what are the parts of the autoscaler. Over here we can clearly see that stable window is 60 seconds. So what it means, so if there is no traffic within the 60 second, this is the window, that 60 second it waits for the traffic, and after that it will again go down and it scale to 0. Grace period we can see over here in the center, it's 30. And you can see the concurrency target as well. If the by default concurrency is 100, so if there is more than 70% concurrency request, so it will expand it. So how it expand, and minimum scale is 0 and maximum scale is 0. What it means, it said by default there is no application running over here and maximum is infinite. So as per the load, by default it will increase as per the bandwidth, as per the resources. And we can see the ingress class, by default ingress class over here as well, the courier ingress networking. So the courier ingress networking is using over here. So we will see the courier system over here. Again, this is the gateway, this is again nothing but controlled by the net courier controller, which created the gateway for it. So all the application hit this particular part, and then comes into it hits the activator, and then all the things happens, right? Now let's focus on the function. This is what we see the function in the slide as well, right? So this is the function which we created, right? We again uses the Kata container FC runtime over here, and the image name is already provided over here. The port is expose 8080, and this is the Python application which we are seeing over here, right? So when we run this thing, and before this, let's check that if the runtime class is enabled, which we have seen, the runtime class is enabled over here, right, in the configuration features. So let's deploy this application. So I deployed this function already. So you can see in the by default service we all have these are the default services we have. This is the Flask application service which is already been created by the deployment part which I created in background. And now let's check the KSVC. So KSVC means Knative service. So over here we can see the URL over here. So this is the host header it provides. So whenever it goes to the courier as an ingress, it uses this particular host header, and then the courier system knows that yes, this is the thing, this is the actual application, I need to forward the request, and then it will see that. Now let's check our systems. Now check I'm just taking a new terminal and log into this MicroVM. system, and I'm just checking the IP address of this system to validate if this is the same system. So ENO1 is saying that it's the same system, so we are just running the command. So I will be running I'm hitting this particular loop, which what it does, it is using this host header and the IP address over there. So I will be just showing what is the IP address. So let's go on this terminal and we will just checking the OC get. Oh, sorry. So I am working with OpenShift continuously, so it's in my mind. So I generally run the OC commands in backend. So sorry for that. So now let's check the service inside the courier namespace. So wait for it. Yeah, so we can clearly see that courier internal. So it has a cluster IP over here, and it exposed in the by default 80 port, and the node port is 32327, right? So over here, when we hit the application, so now let's check OC get kget pods -w. There is no application over here right now. So let's hit this particular loop, and what it does, it buffers the request, and as soon as the request it created a VM, it passes the request. So that is the part of activate, right? We can see clearly that this particular VM is running over here. There is one micro VM which is running already. So over here we can just see this is the title, and we will just this is the again container we are running over here. See, this is a default application which is 302014, which is the part which is a normal deployment service. So we will see over here that this is a deployment service. So kget SVC, sorry. SVC, and we will be seeing over here again the Flask application. See, the cluster IP and the port is the same thing, and now we will be hitting the actual actual service which is on the port. You can see 32327. There is nothing, so nothing worked. The reason is we do not provide any modification in the headers. So as soon as I have add the host header over there, passing that, and if I refresh this should work. Right, so if we refresh it, we can clearly see the application is running. So it is in the background, it is using again, it is deployed like this particular Flask application MicroVM container. So this is sort of a demo which we prepared. So next, so use cases and implementation it will be covered by Nikita. So come over here. Thank you.
Yep. So hope you got familiarized with the Firecracker, Kata containers, Knative, lots more. Let's see some of the use cases and the limitations of MicroVM. Where MicroVM actually shines for the serverless functions, they provide the strong isolation. You can use it for the secure CI/CD pipelines, with the edge computing for your IoT devices, and with the multi-tenant applications with your small overhead. Next comes industries that are using, that are finance, healthcare, government, etc. The limitations that we got here with MicroVM is it is having limited guest OS support. It does not have any limited hardware support, but it's have a limited hardware support. Then comes, it is not idle for heavy workloads, and it does not provide you a fully virtualized environment. Let's see some of the industries that have been migrated from their traditional approaches to MicroVM. So the Amazon Web Services, as you have seen, we have seen that Amazon Web Services have created Firecracker. So they have migrated all their functions. From their traditional approaches to MicroVM. Next is the Cloudflare organization. So they have deployed their container platform to run the untrusted code into a Firecracker MicroVM. Then was Microsoft Azure, and they have also done the same thing. They have run all their sandbox environment, all the testing things into a MicroVM. The key takeaways from our talk was, we have seen about the security, the MicroVMs. It actually achieves the security of VM and speed of containers. Firecracker is a production-ready thing. You can use it with AWS Lambda, AWS Fargate, and even just to run your small tenant application. Ignite comes into picture for your user-friendly. Kata containers is basically used with Kubernetes in order to integrate your Kubernetes with MicroVM. You use Kata containers, and to run your serverless functions, you can use all these technologies. Here are some of the reference links. You can just go through all of these. Yep. So we are up for Q&A.
So any questions? Yeah. So we have to cover under 30 minutes, so it's like.
And my second normal question is, how can you deal with persistence with these micro VMs?
So what exactly is the persistent you are talking about?
Like if your serverless application writes something into the storage, how can you deal with that?
So it's a similar kind of thing, right? So Kubernetes manage everything, right? So if you run Kubernetes or let's say OpenShift, so persistent storage is managed by their controller, right? So everything you attach is to attach the persistent volume claim and persistent volume from the Kubernetes part. So it just use the Firecracker binary to just spawn up the macro VM like that.
Okay, thank you.
Any other questions?
You mentioned that we use micro VMs for CI/CD workloads as well. But as far as I know, like we use micro VMs mostly in the use cases where we have to respond very quickly to a serverless function call. So generally, the response time should be within the limit of a HTTP response.
So the response time ideally over here is around 150 milliseconds. So if that is good, I believe that we can use it.
Yeah, just to add on, if that is applicable with your CI/CD, with your CI/CD workloads, then you can just go with and spawn up an 5 microVM and run your Jenkins over it.
Yeah, so it's not pretty quick like containers, which is having under 10 milliseconds, but it is very quick. It's 150 milliseconds again. It's quick, but I believe.
Also, you mentioned like micro VMs solve the cold start problems. So, like, what is the actual thing that helps with the cold start issues in micro VMs? So, how micro VMs solve the cold start issues?
So it's boot up quickly, right? As we see, it's very start. So it's not. We have just provided the kernel image and the kernel path over there, kernel binary, and it's spawn up. So it skips the, as we mentioned, as we seen in the slide, it skips the bootloader as well. So it directly load the kernel into the memory. It's like that.
Okay.
And pass all the stages.
Okay. Thank you.
Any other questions?
Anyone?
So I thought there are a lot of questions for that. So that